Lesson 6, topic absolute value equations. Learning target, I can solve absolute value equations. First step is to talk about what absolute value is. Absolute value is the distance from 0. More importantly, from 0 on a number line. When we have numbers in numerical order, we're talking distance from 0. So if we look at our examples, we have these straight bars around 5, and those straight bars represent absolute value. So I would read this as the absolute value of 5. Or I would read that as what is the distance from 0 to 5? So if I look from 0 to 5, I have to make 1, 2, 3, 4, 5 jumps. So the distance from 0 to 5 is 5, or the absolute value of 5 is 5. And then our second example, we have the absolute value. Again, those straight bars, they're kind of like parentheses but straight. So they mean absolute value of -5, or the distance from 0 to -5. So we go 1, 2, 3, 4, 5. We took 5 jumps. Just because we took 5 jumps to the left doesn't mean it's -5, because it's a distance. It's how many jumps are we taking. Because I could also take 5 jumps from -5 to 0, go to the right, and still get 5. So that's +5. So if I rewrote this as an equation of the absolute value of x is equal to 5, well, if I look, x could be either +5, because if I put 5 in there, I got out 5, or x could be -5, because -5 also gives me an absolute value of 5. So when we're working with absolute value, we're always going to have 2 solutions, a positive version and a negative version. So now let's put that into practice. We've got the absolute value of x take away 3 is going to be equal to 7. So let's just roll that back here for a second. If I said the absolute value of some number is equal to 7, well, I know that in that absolute value bar, 7 is one of my answers, because 7, the absolute value of 7 is 7, because 7 is 7 jumps from 0. But I also know that the absolute value of -7 is 7, because it's also 7 jumps to -7 from 0. So that means x minus 3, what's inside that absolute value bar, could equal 7. Or x minus 3 could equal -7. Because both of those are going to give me 7. So now I have 2 equations that I have to solve. I'm going to undo the -3 with a +3 on both sides, and I get x equals 10. That's one of my solutions. X is 10. And then I'm going to solve the other equation. The nice thing about these equations is they get solved the same way. I'm going to still add 3 to both sides. X equals, but now, -7 plus 3 is -4. So my 2 answers, the 2 values I could plug in for x up here, is 10 and -4. So let's try another example. We have the absolute value of 3x plus 5 is equal to 17. Well, I know that the absolute value of 17 is 17, because 17 jumps to 0. And also the absolute value of -17 is going to give me 17, because it's also 17 jumps to -17. What that means is this 3x plus 5, which is inside the absolute value bars, has to be the same as whatever is inside these absolute value bars over here. Which means 3x plus 5 could equal 17, or 3x plus 5 could equal -17. So now we need to solve these equations. I'm going to undo +5 with -5 on both sides. 5 take away 5 is 0. We're left with 3x equals 17 take away 5 is 12. Last step is to undo the times 3 with divide by 3 on both sides. We get x is equal to 12 divided by 3 is 4. So that means one of my solutions for x is going to be 4. I want you to solve this second equation. Solve it just the same way we solved the first one, and then put your solution in the blank. You can check your work in Edpuzzle. All right, last example, we have 2x minus 8. The absolute value of 2x minus 8 is equal to negative 9. So we have to ask ourselves the absolute value of what number is going to give me negative 9. And the answer is nothing. If you have absolute value of anything equal to a negative number, that can't be true because the distance to 0 can never be negative. So if you only have absolute value bars over here, there's nothing written outside of the absolute value bars, and it's set equal to a negative, that means we have what's called no solution. That's all your notes for today. Go ahead and move into your practice.